Background and history. Wartime origins. The genesis of the V-2 program during World War II. 1. The V-2 rocket emerged from Nazi Germany's wartime efforts, driven by the ambition to create a game-changing weapon. 2. The program was born out of the collaboration between scientists, engineers, and the military during World War II. Visionary minds. The scientists and engineers behind the V-2 rocket's development. 1. Wernher von Braun, a prominent figure in rocketry, played a key role in the development of the V-2 rocket. 2. The collaboration of visionary minds, despite the wartime context, laid the foundation for advancements in rocket technology. Military significance. The role of the V-2 in strategic warfare. 1. The V-2 rocket was designed as a strategic weapon capable of reaching unprecedented altitudes and distances. 2. Its deployment during World War II marked a shift in military strategies and introduced a new era of long-range precision weaponry. Historical impact. Technological leap. The groundbreaking advancements in rocketry. 1. The V-2 rocket represented a technological leap, showcasing unprecedented capabilities in propulsion and guidance systems. 2. Its successful launches marked a pivotal moment in the history of rocket development. Post-war developments. The impact of V-2 technology on the space race. 1. After World War II, both the United States and the Soviet Union sought to acquire and understand V-2 technology. 2. The knowledge gained from the V-2 program played a crucial role in shaping the early days of the space race. Space race catalyst. V-2's influence on the Cold War space competition. 1. The V-2 rocket's technology influenced the development of early space launch vehicles, becoming a catalyst for the intense space race between superpowers. 2. Its legacy is evident in the subsequent achievements and milestones of space exploration. Historical milestones. Maiden flight. The successful test flights of the V-2 rocket. 1. The V-2 rocket conducted its maiden flight on October 3, 1942, achieving an altitude of 84.5 kilometers. 2. The series of test flights paved the way for the rocket's integration into military operations. Peenemünde Testing Ground, the key facility for V-2 development. 1. Peenemünde served as the primary testing ground for the V-2 rocket, where scientists and engineers refined its design and functionality. 2. The developments at Peenemünde played a crucial role in the success of the V-2 program. Operational deployments. V-2 rocket launches during World War II. 1. The first operational launch of the V-2 occurred on September 8, 1944, targeting Paris. 2. The rocket was used strategically against Allied cities, marking a new chapter in the history of warfare. Technological advancements. Liquid fuel propulsion, pioneering the use of liquid fuels in rocket engines. 1. The V-2 rocket was one of the first large-scale missiles to utilize liquid fuel propulsion, a significant advancement in rocket technology. 2. Liquid fuels provided greater efficiency and control, setting a standard for future rocket designs. Inertial guidance system, the revolutionary guidance technology of the V-2. 1. The V-2 rocket featured an advanced inertial guidance system, allowing for more accurate targeting over long distances. 2. This technology laid the groundwork for modern guidance systems used in space exploration. Supersonic speeds, breaking the sound barrier in rocket flight. 1. The V-2 rocket achieved supersonic speeds, breaking the sound barrier during its flights. 2. This milestone in rocketry demonstrated the feasibility of reaching and surpassing the speed of sound. Challenges and risks. Forced labor controversy, ethical concerns surrounding the V-2 program. 1. The development of the V-2 rocket involved the use of forced labor, raising ethical questions about the means by which technological advancements were achieved. 2. The controversy surrounding the use of forced labor remains a dark chapter in the history of the V-2 program. Technical challenges, overcoming obstacles in V-2 development. 1. The V-2 program faced technical challenges, including issues with guidance systems and structural integrity. 2. Overcoming these challenges required innovative solutions and iterative improvements. Strategic impact, assessing the strategic effectiveness of the V-2. 1. Despite its technological advancements, the strategic impact of the V-2 rocket on the outcome of World War II is debated among historians. 2. Evaluating the overall effectiveness of the V-2 program involves considering its costs, benefits, and broader military strategies. Future prospects. Space exploration influence, V-2's lasting impact on space endeavors. 1. The technological legacy of the V-2 rocket is evident in its influence on subsequent space exploration programs. 2. V-2's contribution to the foundations of space travel continues to shape modern rocketry. Legacy technologies, V-2's role in shaping post-war rocket programs. 1. The technologies developed for the V-2 program influenced the design and capabilities of rockets used in subsequent decades. 2. Lessons learned from the V-2 program contributed to advancements in space launch vehicles. International collaboration, the shared legacy of V-2 technology among spacefaring nations. 1. The acquisition of V-2 technology by multiple nations contributed to a shared legacy, with scientists and engineers from various countries contributing to the advancement of space exploration. 2. International collaboration in the post-war era helped shape the global landscape of space endeavors. Controversies and debates. Nazi technological pioneering, balancing historical recognition with ethical concerns. 1. Acknowledging the technological advancements made by Nazi scientists while navigating ethical concerns associated with war crimes and forced labor is a complex debate. 2. The legacy of Nazi technological pioneering remains a topic of historical and ethical discourse. Military use of rocket technology, the dual-use nature of V-2 advancements. 1. The V-2 program's military origins raise questions about the dual-use nature of rocket technology and its potential applications for both civilian and military purposes. 2. Debates center around the ethical considerations of leveraging military-developed technologies for peaceful exploration. Cold War space race, V-2's role in shaping the geopolitical landscape. 1. The use of V-2 technology in the Cold War space race influenced global perceptions of technological prowess and fueled geopolitical tensions. 2. The V-2 rocket's role in shaping the early space race continues to be a subject of debate. Additional information. Nazi rocket scientists, the post-war fate of key figures from the V-2 program. 1. After World War II, key figures from the V-2 program, including Werner von Braun, became integral to the space programs of other nations. 2. The recruitment of Nazi rocket scientists by the United States and the Soviet Union remains a complex aspect of post-war space history. Museums and exhibits, preserving the legacy of the V-2 rocket. 1. Museums and exhibits around the world showcase V-2 rockets, providing an opportunity for the public to explore the historical artifacts of early rocketry. 2. These exhibits contribute to the preservation of the V-2 rocket's legacy and its role in shaping space exploration. Ethical reflections, considering the ethical implications of technological advancements. 1. Reflecting on the ethical considerations associated with the V-2 program prompts a broader conversation about the responsibility of scientists and engineers in developing cutting-edge technologies. 2. Ethical reflections on the V-2 program contribute to ongoing discussions about the intersection of science, technology, and ethics.